Alright, I'm going to do a couple more from 1.6 because you have several homework problems from that section, and I actually only got through introducing what a complex number was and then adding, subtracting, multiplying, and dividing. So let's look at some more of these types of problems. So 48, for example. 48 asks you to evaluate the power and write the result in a plus bi form. So if I'm trying to figure out what I to the 10th is, I'm going to start with what I know I is. Well, I know that I by definition is square root of negative 1. I know that I squared by definition is negative 1. So let's just keep going with that. What would I to the third be? Let's establish a pattern. So I to the third I could actually rewrite using I times I squared, because my product rule tells me if I multiply like bases, I add the exponent, so that would be 1 plus 2. So this is just another way to rewrite this. And so by definition, I know that's by the square root of negative 1 times negative 1, which if I'm writing this in a plus bi form, I know that that is I, and so it's going to be negative I. Alright, so I cubed would be negative I. What would I to the fourth be? Well, I could do the same thing here. I could split this up into things I know. Well, I know that I squared times I squared is I to the fourth. Because of the same product rule, it tells me I add those exponents. So that's going to be negative 1 times negative 1, which is a positive 1. That's a good thing. Alright, if I keep going here, I to the fifth. So let's do I to the fourth, because I know that's 1. And then that would be multiplied by I. That would give me I to the fifth. So this is just going to be I. Alright, well, I am back where I started from. And I could keep going, and you will see that I to the sixth would be the same thing as I squared. Then I to the seventh, the same thing as I cubed. And then I to the eighth would be back to 1. Alright, so that's what we're going to use in order to rewrite these. Alright, so let's think about I to the 10th. How could I write that using the information I know? I mean, these are the things that I want to use, right? Because once I get here, I start repeating. Well, I to the 10th, I could rewrite that as I to the fourth times I to the fourth times I squared, right? Because I'm still adding the exponents, and that gives me 10. So this is I to the 10th. Alright, so that's just 1 times 1 times I squared, and I know that I squared is negative 1. So I to the 10th is going to simplify to negative 1. Alright, another way I could have written that is I to the fourth. How many of those do I have? Well, I have 2. This is my power rule. It tells me I multiply the exponents. So that's I to the 8th, and then it's the same thing. Okay? So if I come down here and they ask me something like I to the 1002. This is actually number 52. Alright, what I'm thinking is I want to break this down into I to the fourths, because I to the fourths are 1, and then if I have any left over, then it's going to go back to one of these 3. Otherwise, I'd have another 4 in there, really. So how many 4s do I have in 1002? Well, 4 times 250 is 1,000, so there is I to the 1,000th, and then I have 2 more left over. See what I did there? I divided that by 4, because that's going to give me my power rule, so I to the fourth, and that goes in there 250 times, and then I am left with I squared. So all this is going to simplify to I squared, because I know this is 1 to the 250, which is trivial because 1 raised to any power is 1, and then I squared is negative 1. Alright, so that's what 52 is. So really you just break them down to powers of 4, and then you're going to be left with one of these, and that's going to give you what you're looking for in a plus bi form. Okay? Alright, let's do one like 55. And the reason I want to do one like 55 is because I want you to be careful. I have a product rule that I don't know if you remember, but when you started working with radicals and learning radicals, and you should remember that if you've got like radicals, which I do, I have 2 square roots here, I can multiply what's underneath the square roots. Well, if I do that, I get a negative 3 times a negative 12, which is a positive 36. Alright, well, I cannot do that here, okay? You have to take care of the imaginary part first. Alright, so I'm going to simplify this first. So this is going to be the square root of 3 times I, because the I is going to pull out. Remember, this is negative 1 times 3. Alright, and that's negative 1 times, I can break that up in my product rule, so I've got the square root of 3 times I. Here, let's look at square root of negative 12. I'm going to do the same thing here. So I've got negative 1 times, alright, now when I'm simplifying a radical, remember I want to take out any perfect square factor I have. So really, that is negative 1 times 4 times 3, or square root of negative 1 times the square root of 4 times the square root of 3. And that's not usually, I don't usually write out all those steps because this is a perfect square and this is my I. Alright, so this is going to be 2I times the square root of 3. Alright, so that's what the square root of negative 12 simplifies to. Alright, now when I multiply these two terms, I get I times 2I, which is 2I squared, sorry. And then I get the square root of 3 times the square root of 3. And we know that when you multiply square root by itself, the radical goes away. So that's times 3. Negative, I squared is negative 1, so that's going to be negative 2 times 3, or just negative 6. And this is important because if you'd multiplied these two originally, you would have gotten a positive 36, and that's not what we're looking for. Alright, so make sure on those that you take care of the imaginary part first. Alright, let's do 2 more of these. So, unlike before, if I were trying to find the real solutions to this, I would look at that and go, there are no real solutions, because I'm looking for the zeros, or what I plug in to make this 0. I know that anything squared is going to be positive, and if I add 49 to that, the smallest number, this could be 0. And if I add 49 to that, there's no way I'm getting to 0. Alright, so now I've introduced this whole other set of numbers called complex numbers. And I'm not going to solve it any differently, except when I subtract 49 and I take the square root of both sides. Then I'm thinking, alright, first of all, you need to remember that when you take the square root in an equation, when you introduce the square root in an equation, you've got to do the principal square root and the negative. So there's where your two answers are going to be coming from. And then I'm looking at positive or negative square root of negative 49. Well, we've already talked about this enough to know that this is going to be negative 1 times the square root of 49, or positive or negative I times the square root of 49, or positive or negative 7I. Okay. If I go on and do number 68, the first thing I'm looking for when I solve a quadratic is see if it factors. Well, obviously I can't multiply two numbers to get 3 that add to give me negative 3. So you're going to have to either complete the square here, or you're going to have to use the quadratic formula, which is probably what you're going to do. So I'm just going to review that very quickly. So there's my quadratic formula. In this case, after I've got my equation set equal to 0, then I know that A is 1, B is negative 3, and C is positive 3 in this case. So now I'm just plugging this into my formula. So I've got a negative B, so a negative times a negative 3 is the positive 3, plus or minus the square root of B squared. Negative 3 squared is 9, minus 4 times A, which is 1, times C, which is 3, all over 2 times 1, or 2A. Alright, and cleaning this up, this is just going to equal 3 plus or minus the square root of 9 minus 12, which is negative 3, all over 2. And this is going to be 3 plus or minus I times the square root of 3, because that negative 1, by definition, is I, so that's coming out all over 2. And you're almost finished here, unless it specifies to write this in a plus bi form, and remember to do that, you just split it up. You split these terms up. So, and I'll go ahead and split the positive or negative up too. So I've got 3 over 2 plus the square root of 3 over 2i. That's one of my answers. And then I've got 3 over 2 minus the square root of 3 over 2i. So those are my two complex zeros here.